Okay, so there is going to be something unique that happens with this that affects a lot of things. So we're going to start by putting the variables together as always. And putting the constant on the other side. Everybody good with that idea at this point? What is my coefficient of x squared? 4, so I'm pulling it out. Completing the square. And then adding 4 on the opposite side. All good? Make sense? All right, now I'm going to do a little bit of factoring. Clean up a little bit. 4 times x plus 1 squared minus 3 times y squared equals negative 12. Now, with a hyperbola, just like an ellipse, we need the right-hand side to be equal to 1. The difference is, what type of number are we dividing by? Negative. When that occurs, the x and y are going to switch spots. So now the y squared is going to come first, because instead of negative, that is now positive. The x squared is going to come second, because that's now negative. All right. Everybody good with that? So when you divide by negative, you have to flip your sign. So everything changes. So that means the vertical is where everything's going to fall on. The opposite of positive 1, negative 1, 0 is 0. So that's going to put my center at negative 1, 0. Because the y comes first, that's going to give me my vertices. What's the square root of 4? 2. So I'm going to go up 2, down 2. That's negative 1, 0. That's 2, that's 2. All right? Now, I'm then going to look at my other fraction, which is 3. I'm going to estimate the square root of that, which is about 1.7. So I'm going to go over about 1.7 in both directions. I'm going to estimate it. I'm then going to make my box. I'm then going to create my diagonals. Remember, those are your vertices, so that's where your curve's going to hit. So I'm going to create a curve that hits it there. I'm going to create a curve that hits it there. So my vertices were at negative 1, 2, and negative 1, negative 2. What coordinate is the same for all of them? The x, which is what? Negative 1. So that's going to be the x coordinate of my foci. I'm then going to take my two denominators and add them. What's 4 plus 3? 7. God bless. That means c squared equals 7. So c equals plus minus square root of 7. So I'm going to come back up here. Your choice on whether you want to write the 0 or not. Plus minus square root of 7. And that's how you handle graphing. Fantastic. All right, let's work on an equation. So find the standard form of the equation of the hyperbola. Find the standard form of the equation of the hyperbola. So my vertices are at 4, 0 and negative 4, 0. So So 4, 0, and negative 4, 0. Make sense? It's horizontal, so that means x is coming first. So the direction of your line of your vertices is your first coefficient. So that's going to have an x in it. Then the y is going to come second, and then that's going to be equal to 1. Now, to get that center, I find the what point? Midpoint, halfway through. What's negative 4 plus 4? 0. And what's half of 0? 0. So that's my center, 0, 0. So your choice if you want to write the minus 0 or just write it as x squared, y squared. If it has a number, you write that as a minus. Now, A is the distance from the center to the vertex. How far is it from 0 to either 4, 0 or negative 4, 0? 4. What's 4 squared? 16. They then give you the foci. The foci is out here. The foci will always be outside the curves. How far is it from 0, 0 to 6, 0? So that's your C. And C squared equals A squared plus B squared. The C squared is 36. The A squared is 16. I'm solving for B squared. 36 take away 16 is going to leave me with what? 20. That's my denominator, my second factor. Good? All right. You're working on those two, please.